to show you what's a Spock. A Spock is a Groovy-based testing framework for Java and Groovy applications that makes writing tests fun again. We can write a highly expressive and really beautiful test because of the DSLs that Spock provides us and all the power, all the Groovy power. So Spock is totally compatible with your standard tools. So it's compatible with JUnit. So you can use it with your tools, with your IDEs, with IntelliJ, Eclipse, NetBeans, your build tools, such as Maven or Gradle, or your continuous integration servers, for example, with Jenkins. So during this talk, what I'm going to show you is a lot of nice features about the Spock. So maybe at the end, you want to try it or introduce Spock in your current project. But first, let me introduce myself very quickly. I'm Lopez, on Twitter. I've been using Groovy on Rails for the last 7 years. Now I work at OCI. OCI is the home of the Rails team. And now I'm a member of the team at OCI. OCI is sponsoring the development of the Rails framework. I'm the coordinator of the Madrid Groovy user group, our local group there. I live in Spain, in Madrid. We have meetings once a month. And I also organize Reach. Reach is a Groovy conference in Madrid. Last edition was the 6th, and it was a month ago. You have all the information on our webpage. If you are interested in Groovy or any tool on the Groovy ecosystem, go to the website. All the videos are already online. And I also have there some t-shirts from the last edition and some buttons and stickers, so after the talk, you can grab a few of them. And I'm also a regular speaker at different conferences. I like to enjoy giving talks about this thing. So, I could spend something like, I don't know, 20-25 minutes of this talk talking about why it's important to test our applications. But I'm going to assume that you test your application, right? Do you write tests, please? Yes? Only a few of them. But if you don't write tests, at least I think that you know that it's important to write tests, right? But so as I said, I could talk a lot about a lot of theory, but we are developers, and I like to see code. So this is basically my last slide, and now I'm going to show you something like a Spock in action, right? So I have here. Can you see the font? No. Now let me switch to presentation mode. Better now? So this is a Gradle project. Don't worry about the code. I will push the code to GitHub and I tweet with the link of all this code. And this is a standard layout for the project, source main Java. Here I have all the code, all the Java code that I'm going to test. And here I have the test Groovy, and all the tests, right? And this is the build.gradle file that you need to introduce just Spock on your project. Actually, the only thing that you need is this dependency. That's all. If you use Maven, you can add that POM with this artifact, and that's fine. And for Gradle, you only need to apply the Groovy plugin, define your repositories. You can use Maven Central, you can use a center, which is a superset of Maven Central, and just add Spock as a test compile dependency. I'm using the latest 1.1. It was released just 2 days ago. Before that, I was using the release candidate 4. Okay, and that's all you need. Spock will grab Groovy dependency, transitive dependency. But if you want to use the latest Groovy version, you need to add it because Spock 1.1 is using Groovy 2.4.9. So I want the latest one. And that's all you need. So let's start with the first example. The first thing you need to do if you want to write a Spock test is create a test, a class, and you need to extend from specification, from Spock lang specification, right? That's all. And in this class, as I said, it's compatible with JUnit. So this specification, it's annotated with this run with, which is the JUnit runner, right? But you don't need to worry about it.
The name of the Spock runner for JUnit is this Sputnik. This name came from Spock and JUnit. And here is a lot of things, but you don't need to worry about it. This works only for writing things, right? So you write the first your class, extend from a specification. Now you can start writing your first test. The first thing that you can see is that the name of the test. You can just write in plain English. Should reverse in a string. You don't need to write in this camel case with a method name that sometimes is not very readable. You can write here whatever you want. And then Spock forces us to write the test in this BDD form, this given when then blocks. So in the given, I have my setup for my test. I'm defining this string, hello world. Then in the when, I put the test that I want to test. In this case, I want to reverse that string. And finally, in the then block, I write my assertions. I don't need to write here assert. Right? Everything here and then are assets. And that's all. If I can run this test. Compiling. Okay, green. It passed. And another thing that you can see is that you can write here a small text explaining what you are trying to do. This example is pretty simple, but when you have a more complicated test, writing just a few words explaining the things, it helps you to read the test. Another thing, as I said, is that Spock forces us to write the test in this way. So for example, we can do something like this. We can put here the then block. If we try to do this test now doesn't compile, because then is not allowed here. We need to write test the good way, right? So if you use, for example, JUnit, you can do something like this. You can write your given when then blocks on comments, but it doesn't matter. I can mix everything, right? With Spock, you are forced to do it right. And another thing I want to show you about this very basic example is that sometimes this is a little verbose for just a simple test. I only want to try. I only want to reverse a string. So we have this more compact version, which is expect. So I'm expecting that when I reverse this string, this is the result, right? Pretty simple. Let's move to the next one. So what happens when a test fails? If you are doing TDD, you know that the first thing you need to do is write a red test, a test that fails, and then fix the test with the code. So it's important to have a well support for when a test fails. So you have a few annotations here. I have this at ignore. So with this annotation, the class will be skipped, right? I'm going to comment it. But Spock has another really useful annotation, which is ignore rest. Imagine that you have this class with, I don't know, 20 tests, and you are only focused on this specific one. You can annotate that test with @ignore rest, and Spock will only execute that test, not all the tests in that class. Right? Let's run this first one. So it's going to fail because 6 is not 20. And you can see here, this is the output. 2 times 3 is 6, and 5 times 4 is 20, and of course they are not false. This thing of presenting an assertion when it fails, it's called power assert. These power assert were developed on Spock a lot of time ago, and then they were moved to Groovy core. So if you now use Groovy and write an assertion and it fails, you will have this output. This is a very simple example, but sometimes you have different variables, different steps, and you don't know why the test is failing. So I have here another example. This is a map with these keys, and here is a child list. And what I expect is that the name of the first child in this list is Adriana, and it's going to fail because it's Judith. So if I run this test, you can see this power assert, this result. You have all the values in every step. So in data, you have all the variable, all the data there. Then we extract the child, which is, let me do this. Only this key, right? This is a map. And you can see here the name, of those childs. Then I just extract the name, Judith and Adriana, and the first one, Judith, which is not Adriana, right? It's false. So you don't need to put a breakpoint on your test or write a lot of print lines to see all the values in every variable. You have here all of the values here. And you can also see here that these strings are 40% similar, right? This is, I think, I don't know why they add this. And the thing is that both Judith and Adriana are more similar because they are both sisters and are my daughters, right? But as you can see, you have all the information when the test fails. Another thing that I want to show you is how you can test your Java code, right? Because with Spock, you write your test in Groovy. You can use here Java if you want, but with Groovy you have a lot of different options and more powerful to do some tests, right? So I have here this class. This is a Java class, right? You can see the semicolons. It's really verbose. And here I have this Fibonacci sequence, 1, 1, 2, 3, 5, 8, and 13, right? And I'm going to, this is just a list of integers. So what I'm going to do is I'm going to add a new number to that list. This left shift operator is overloaded in Groovy. So you can use this, or you can just add numbers.add, as you will do in Java. And now I can check that after adding the number is there. So here I'm mixing code, I'm testing all this Java code. Remember that this is a list, right? And I'm testing from Groovy. So I can run the test now. And it's green again. But let me show you a more complex example. Here I have this list of users. So this is all this code is Java code. It's a user class with name, last name, a couple of constructor, and setter and getters. Nothing new here. And here I'm returning just a list with 4 users, right? So let's see what thing we can test with Groovy. So let me do this, and I'm going to just put this here. So the first thing that we can test is that the size is 4, because there are 4 users in this list. Then we can check that the names of the users in that list are Selvo, Leonard, Rajan, and Howard in that particular order. Then we can sort the names alphabetically by default. So now the names are Howard, Leonard, Rajan, and Selvo. Here with collect, we can get a new list with the size of the last names, right? So the size of Cooper is 6, Hofstadter is 10, 12, and 8. And then with this last line, we can extract the name of the user with the smallest name, right? And how many of you know a little bit or something about Groovy? None of you. 1. Yeah, you are in the right room. So maybe this thing, it's something like why this is working, right? Because users, remember, it's just a Java user, a Java list with users. And you are writing users.name, which, I mean, name doesn't exist on users, right? So let me do this. You can do something like this. In Groovy we have this, is users. This is spread operator, which basically means I'm going to execute something in every element of that list, which in this case is extracting the name. You can also do something like this. User.collect. Collect is, if you know anything about Java 8 and lambdas and strings and all that stuff, collect is it's something like a map. I'm going to apply a function. In Groovy we have closures, so I can say for every element on that list, I want to extract, I want to extract the name, right? IT is the default variable for every iteration. I can also write this code in more something like a Java way, so I can define user u and u.name, or even get name, right? It's the same. In Groovy, when you use this property access, you are not accessing the property. You are going through the getter, right? It's the same. And I can also write this last version using, for example, Java 8. So I can string that list. Now I can map And now here I need to apply a function. In Java, you will apply a lambda. Instead of a lambda, as I said, we have clauses. So I can say user and u.name, or even, sorry. And then I need to collect, for example, to collectors to list, right? Or you can, for example, write this, as I said before, get name. So now I'm going to run this test, and all the prints should be the same, right? The names of the users in that list. So I'm going to delete all those intermediate steps, because I want to show you these two different lines. Now that you know that you can access elements or property of some elements in a list using Groovy with this annotation, think about it. If you want to test this in Java, you will need to write something just like this. And I'm not saying it's not readable, because, well, you stream that list, you extract the names for every user, and finally you create a new list. But I think that you will see that this users.name, it's way more readable and it's more compact, right? That's one of the great things about using Groovy for test code, because it's more compact, it's not verbose, you have a more helpers to do a lot of things. And the last thing I want to show you in this example is it's about with a map. Here I have a map. I put this name, Ivan, last name, and age. I will just return the map. Again, it's a Java map. So what I'm going to test is I'm going to remove the name, that key. So let me do this again and put it here. So if I remove the name, the size of the map now is 2. The key set doesn't contain name. And here you can see 3 different ways to get an element from that map. This is the Java way, map.get. But in Groovy you can just do something like this: map dot and the name of the key. And if the key is not present, the value will be just null. Okay? So as exceptions. Sometimes you want to test some code that throws an exception. So here what I'm trying to do is convert this foo, this string, to a long, and of course foo is not a valid long. So what is going to happen, what I expect, is that number format exception will be thrown. So you can do this, thrown, and the exception you want to test needs green, right? But you can do more things. So instead of just checking this thing, you can store that exception in one variable, and now you can make assertions on that exception. So you can write, for example, you can see here that your IDE knows that this is a number format exception. So you can extract and check whatever you want. So I'm going to check that the message, let me check my notes, it's for input string foo. Correct. Yeah, the space and the quotes. Right? Green again. So imagine that here, instead of using number format exception, you throw your custom exception with a lot of fields, with an error code, with an error message, with anything you want. You can check here exactly that you are testing what you think you are doing, right? But there is another option. Let me cheat a little bit, copying this code. Should not throw an exception. What happens if now I try to convert a valid number? So for example, 1, 2, 3, right? I have here thrown, but I also have not thrown. Not thrown number format exception, right? In Groovy, parentheses are optional most of the time. So writing this not thrown here, it's the same as this one. You can omit parentheses if you want. And this test is green because that exception has not been thrown, right? And the last thing I want to show you about this is what happens if I expect, let me delete this, a different exception. For example, null pointer exception, which this should be wrong. You shouldn't expect throwing a null pointer exception on a test, right? So the test is red, and we can see here the output. Expected exception of type null pointer exception, but instead we got number format exception. Okay? You can check a lot of things with these thrown and not thrown methods. Okay, data tables. This is for me one of the most interesting and killer features of Spock. So sometimes you need to test code that it's just the same code, but you need to test that code with a lot of different inputs, right? Imagine you are developing some complex algorithm, and you want to put a lot of different values in that algorithm. In this case, it's pretty simple. I'm just checking that the number it's an even number. But imagine that here, it's a very complex setup with a lot of things. What Spock is going to do here is, it's going to replace number for any of those values in every iteration. So it's going to test this number, -10, 0, 2, 42, and 1000 in any iterations, right? With this left shift operator and a list. I can run the test, and it's green because all the values are even numbers. We can also write more than one variable here in this word block. So I can, for example, check that the minimum between x and y is result, and you can just define more variables here in the word block. And this word block is written in column mode. I mean, for the first iteration, the minimum between 1 and 2, it's 1, and then the other columns, right? So this has a problem that we humans read more in line mode. So we can rewrite or reword this test, something like this. Sorry. We can create this table, right? So these two examples are the same, that we have this data table. So now if we want to add a new variable, a new test, it's pretty simple because we only need to do something like this. Whatever, and you don't need to worry about formatting your table because your IDE is smart enough to do that for you. So I can now run this test, and it fails because this value is not valid. So, but imagine that you have here a lot of values. You don't know which value makes the test go to red, right? So we can improve this test with this unroll annotation. So what the Spock is going to do now with unroll, let me make this test fail. It's going to create a new output on our test report for every line here. So now we can see 3 different outputs, right? And we can now see that the second iteration fails. But yeah, this is better than the previous example, but we can even do it better because we can also here put the names of the variables in the description of the test. So if I run this new version, we can see that, for example, the minimum between -1 and -2, it's -1, it fails, right? We can replace the variables. And the last example I want to show you about this is this. Here I use a list. This is a Groovy list, and just an array list. But actually you can use here anything that is iterable, right? It doesn't need to be a list. So I have here this users file, this just a CSV file. I'm going to add a new value. And what I'm doing here, let's start with the word block. I read that file, I read all lines, and I create a new list, splitting by comma. This is a very, very ugly way to parse a CSV file. It's fine for a test and for a demo, but if you try to parse a CSV file on production, please don't do this. Use a library. There are a lot of libraries to parse CSV files that just works. But for a test, as I said, this is good, or it's not that bad. So what I'm doing is I read every line of that CSV file, and I create a new list with these 2 variables, right? So now we go back to the given block, and here what I'm doing, this is a map, this is the key, and this is the value, and this is the key, and this is the value, right? This is just a hash map. And what I'm doing here with this as user, it's doing a Groovy trick. This is called coercion. I'm coercing, I'm transforming this map to a user, to an instance of this. Remember, this is just a plain Java class. And this works because I have these 2 properties, name and last name. So the first thing I want to check is that this user instance now, it's actually an instance of that class. And then I can check the name and the last name that are the same that are here. But as you don't believe me, probably, I'm going to do something like this. Unroll, and I'm going to add here name. And as you can see, your IDE knows that you can use those variables on that description. Name and last name. The last name. Oh. So if I run this test, we can see here in the output the 5 iterations, one per line on the CSV file, and you can see that's the name. Here is the name that I defined here with my role annotation. Okay, let's move to the next one. Life cycle. I have here only these two tests that just print something. And with Spock, you can define these 4 methods to just hook into the execution of the test. Setup expect will be executed at the very beginning of all this class only once, and cleanup expect will be executed the last one. And setup and cleanup are executed before and after each test, right? So if I run all the tests in this class, we can see first setup spec only once at the very beginning, cleanup spec only once at the very end, and then before and after each test. Remember that my tests are only these two, test and test 2. So we can see setup, test, cleanup, setup, test 2, cleanup, and so on and so forth. So you don't need to define these 4 methods. You can use any of those. For example, if you want to initialize some object, open a database connection, do whatever you want, you can do it here, for example, with setup spec, and after all the tests, you can close all the resources that you use. So imagine that now you need to share some instance in different tests, right? Because here I'm just creating a new user, which is really cheap to create. But imagine that you need to create something that is expensive to create this resource, and you want to share it for all your tests. You can just, if you put here on the level class and run the test, you can see that the users are not the same, right? So we are not sharing anything. We are creating a new instance of a user for every test. So this code is something like doing this devs tab user, right? It's the same because setup is executed before any test. So maybe if you remember the previous example, you think, okay, instead of using setup, let's use setup spec, right? Because it will be only executed once at the very beginning. Let's try it. And the thing, this code doesn't compile. We have here a compilation error because we can use these variables from setup spec only at share or static fields. So actually, this is the solution. We can say we can use this annotation at share, and with this annotation, now if I run the test again, we can see that the user is the same. So we achieved 2 things with this annotation. The first one is what we were trying to do. It's just sharing that instance for all the tests here. And the second one is that we are documenting our test. Because if you don't know anything about the Spock or you are just learning, if you see this annotation at share, maybe you think, okay, this is share, or you can go here and read the documentation, right? Because it's important to write a readable test as much as a production code. So mocking. This is really important. When we test real code, maybe we have this piece of code and we want to test it, but here we have, for example, a collaborator. And when we unit test this code, we don't want to worry about this code because we are going to unit test this code in another place, right? So if you use JUnit or something like that, you from Java developers, you use, for example, Mockito or EasyMock or something like that. For Spock or with Spock, you don't need to add new dependencies. Spock has a built-in mocking framework or mocking libraries. So here with what I'm going to do is use that to mock this collaborator. This is what I want to test. I want to create a new user, right? And this is the Java code that I'm going to test. Imagine that you receive a name and a last name, you create a new user, store anything on database, put here all your business logic, and then the last step after creating your user is just sending a notification, for example, an email saying your account has been created, right? So this notification service, it's just an interface. I don't have the implementation, it doesn't matter. But I want to mock this because I don't need to worry, or I don't want to worry about this when I test this code, right? So what I'm going to do is use this mock. Here I'm creating a fake object, an empty object for this interface, and what I want to test is just behavior. So I want to test that this method is executed, and I can do this here. When I execute this code, what I want to make sure is that this method, send notification, has been executed once and only once on that mock, right? And I can also check that the second parameter is user created, because here it's user created, right? So for the first one, putting an underscore means I don't care about it. So I can run it, and it's green. And what happens if tomorrow I refactor this code, I do a lot of things, and I forget to send the notification? I can run the test again. And then the test, it's going to fail because there were too few invocations for that expectation, right? And let me fix first the code. And another thing I want to show you here is that sometimes you have different parameters, you want to check some of them, but sometimes you don't worry about the parameters. So you can say something like this, start underscore, and it doesn't matter how many parameters, you don't care. You only are caring about this method, send notification, right? I can run it again. But sometimes you don't even care about the method, so you can put a new underscore, or you can even care about the mock. You can put another underscore. And finally, if you don't even care about the number of executions, you can put here another underscore, right? So I'm going to run this test. Actually, I'm not testing anything, or I'm not checking anything, because in the then block is, okay, I don't care, right? Don't write like this. The only option, or the only valid thing, or valid option to write this kind of thing is when you have something like this. Instead of checking anything, you can put here 0. This means I want to check that this mock has been executed once, and then if any other mock on any other method is executed, the test will fail because I'm expecting 0. And this is common, so there is a shortcut for this, and it's just doing this. 0, whatever, right? And you can do a lot of things. So for example, you can check from 1 to 3 execution. You can put here, if you want, a regular expression. There are a lot of different options. You can check all of them in the Spock documentation. Another thing that you can do here, remember here I didn't care about this parameter, but you can do something here. The thing is that this user, it's just a private variable that I'm creating inside this method. So I cannot access this user from outside the method. But with Spock, you can do something like this. You can put here a closure, and inside of a closure, you can do whatever you want. You can put something like a predicate in Java 8, something that needs to evaluate to true or false. So in this case, I know that that's a user, so I can check that the name is Ivan. And sometimes, as you can see with this yellow thing, IntelliJ complains a little bit about me. So maybe you can help IntelliJ casting this as a user. But it doesn't matter. This with this thing, it also works, right? It's only for IntelliJ. And here in these examples, I was testing, or I was mocking an interface. But sometimes, let me show you the next example. You need to mock an implementation. It's not the best option, but sometimes this is an external library and you don't have an interface, you don't have another option, but you need to mock that implementation. So for mock that implementation, remember those lines here? Well, I forgot to mention that I only need to add this empty SLF4J implementation, because if not, it will complain on every execution that there is no implementation. And this, if you want to mock an implementation, you need to add CGD on the class path. Just add this line, and then here you can mock an implementation. If you forget about it, don't worry, because Spock will detect that you are trying to mock an implementation, and on the error you will see, okay, you are trying to mock an implementation, please add CGD on the class path. And now it's the same. I create a new mock, and I can execute something on that mock and check that this is what I expect. And the last thing I want to show you here is about the order. Imagine that you want to send 3 messages, and you want to check that the messages are received in that particular order. Message 1, 2, and 3. Right? You need to put 3 then blocks. Let's run it. The test is green, and if I change, for example, the order of the messages, now the test is going to fail. Okay? But it only fails because I have 3 different then blocks. If I delete this and put everything on the same then block, the test is going to pass again. And this is not what you want, right? So if you want to check the order, you need to make sure that put everything on different then blocks, because inside of the same then block, Spock doesn't care about the order. And the next one, it's about the stub. So in the previous examples, I was smoking this collaborator, which means I replace with an empty object. With an stub, instead of replacing that collaborator with an empty object, I replace with an object that will return some value that I need for my test to continue. So for example, here, imagine that I have this interface with these 2 methods, and I want to replace any of those methods with a value that I want to return. In the first case, I need to return a user, and in the second one, a list of users. So what I'm using here is a stub. This also came with Spock. I put here the name of the method that I want to stub, to replace, and here I need to return something that match that signature. Remember, I need to return a user. So I return a user, new user. So when I call this method on this stub repository, this stub object, this user will be returned. So it's John Doe. And here with the underscore, again you say, I don't care about it. You can also put more than one value. So here I was using this right shift operator. Here with another one, I don't know the name of this operator, and a list, you will return a different value for every iteration. So for the first one, you return the first user, right? John Doe, so username 1 is John. For the second one, you return the next element on that list. And for the third, for the fourth, and so on and so forth, if there are more invocations than users on that list, Spock will always return the last value. That's why for user 2 and 3, we have Jane here, because it is the last element on this list. We can also return different values depending on the input. So here I said I don't care, but here with 11 I will return this user, John, and with 20 I will return the other user. I can also throw an exception, right? Because sometimes the code that you want to test throws an exception, and you want to make sure that you catch that exception properly. So you can put that code inside of a closure and throw the exception you want. And as we saw in another example, we can check again the message, user that does not exist. And in this last one, we can mock or we can stub more than one method. Remember here, our interface has 2 different methods. In all those examples, I was only mocking one of them, but I can mock or stub different ones, right? And I have this. I think this is the last one I want to show you. Imagine that you want to check that the size of the list has changed. So this is how you write an array list in Groovy. Remember that Fibonacci sequence? And I want to check what happens when I add a new number, right? So I want to check that when I add a new number, the size has been increased. So we can do something like this. Number size numbers.size. We save the value, and then after adding the value, we said, okay, now the numbers, the new size of the numbers is the old one plus 1, right? And it works, and it's good. And we do that because we are developers, and this is how we think, right? We know that if we want to check something here, we need to save it here. But we do that, as I said, because we are developers, but regular people, plain not developer people, don't think like that. Our brains don't think like that. You say, okay, I add a new value, so now my current value of the numbers.size, it's actually the old value of numbers.size plus 1. This is how our brain works, right? It's the old value plus 1, and it's the same. With this old method, what Spock is doing is, okay, you want to check this later, so it will put this number size, we'll move to the given block, we'll save it, and we check it after the then block. Okay? I have two few examples, so I have 3 here. You can check it after the talk because I don't have more time. I only want to finish with one more thing. Big.Gradle. You can add this new dependency, test compile, this is Spock reports. So what I'm going to do, let me exit presentation mode. So what I'm going to do is I'm going to run all the tests. I don't mind, or I don't care if some tests are green or are red. I only want to run all the tests in my test suite, because I want to show you the report. Okay, running. And here on the build directory, we have these test results. So reports, and I can see, you can see here, open browser. This is just a Gradle standard report. Some tests has failed, some packages, some reports, something. It doesn't matter. But as we add, it's on the other screen. These Spock reports, we have this new output, this new directory. So I can open this report. It's pretty much the same information, but there are 2 different things that I want to show you. The first one is, in this basic, you only have this is the Spock, sorry, the Gradle report. Here, in basic, you can see that you can extract all the tests that I write, all the definition, and in the data-driven, you have all the data, all the tables that you put there, right? And the thing about these Spock reports is that you can customize these output, these 2 reports with your company logo, with your CSS, whatever you want. And let me do this. That's all. This is the 3 URLs, the Spock framework, the GitHub webpage, and the documentation. And this is my contact information. I will put the slides online and the code. And in this QR and that URL, if you have only 30 seconds, please go to that URL. It's an anonymous Google form to send me some feedback. It's anonymous, so it would only take 30 seconds. So if you like the talk, please let me know. If you don't like it, send me something because it's important and it's anonymous. And you can grab now some t-shirts and pins, and I think I'm done. Thank you very much.